Now, the previous 2 or 3 videos have all been about fission and fusion reactors and basically the benefits of nuclear power. Again, both of them are very clean forms of energy as opposed to fossil fuels, which are basically polluting our environment every single day. We don't really think about it because it's just on a small scale, but um, it is really, really damaging our planet significantly with the fossil fuels. Nuclear power, again, can provide a much cleaner form of energy. Yes, there have been some pretty bad accidents, but on the whole, it's a very, very clean form of energy. So there's a lot of really good things that come with nuclear power. Well, like all things, there's also some, well, I want to say arguably, but I'm not sure if that's really arguably, some really bad things that come with nuclear power. And that is, of course, our development of nuclear weapons. And yes, the US was responsible for this. So we're going to talk basically about this in a somewhat chronological order for the most part. So we'll see. So the first thing we're going to talk about are what's called atomic bombs. These are the very first nuclear weapons that were ever created. And again, this was basically around the time of World War II. World War II, there was a massive rush to discover nuclear technologies and nuclear power. And of course, while one avenue split off to make nuclear power and the good stuff, of course, we went out the other way and also made nuclear weapons. So the atomic bombs use nuclear fission, again, which is where you split atomic nuclei apart. And so what you see right here is the Bikini Atoll at a test in 1946. This is just one of many hundreds of tests of where we detonated nuclear bombs, either in the atmosphere, on the land, or under the water, or even underground. This particular test was at the Bikini Atoll, like I said, the Marshall Islands. They had about 95 ships parked out in that bay, and they wanted to see how effective nuclear weapons would be against warships. So they parked them all out there, and they detonated a bomb under the ocean right there. Again, it's very shallow, and just to see what would happen. By the way, the Bikini Atoll now is highly radioactive and nobody lives there, and it's mostly gone because we've blasted the crap out of it. But this image was taken like a couple milliseconds after the explosion itself. So the majority of what you see in right there is water vapor. The excessive pressure caused by that detonation is actually forcing the water to condensate. So majority of what you're seeing is just water vapor. The mushroom cloud is behind that in the very center and up to the very top. That's the mushroom cloud. The rest of it that looks like a cloud is water vapor. But very impressive image, at the same time, very, very scary. All right, so the 2 most famous atomic bombs ever invented were Little Boy and Fat Man. Little Boy and Fat Man were 2 different types of bombs. One was eventually used against Hiroshima, and the other one was used against Nagasaki. Both of them were used again to end World War II. So the top one you see is Little Boy. Basically, the way it worked was like a gun barrel type. So what we have here is we have a uranium target here, and then we have a hollow uranium bullet. If you remember from an earlier video about critical mass. Critical mass basically means you could have 2 radioactive masses, but if they are not at the substantial critical mass, then the chain reaction will not begin. So both of these, uranium bullet and the core, are highly radioactive, but they are not enough mass in order for this thing to actually detonate and create a chain reaction, which we would call a nuclear explosion in this case, because again, we're not trying to control it, we're trying to unleash it. So when it falls straight down and hits the ground, then this bullet here would then shoot down and surround the target, which would then give it the critical mass that is necessary for the detonation. So you can see right here, again, this is another schematic. We have these 2 masses when they combined. Again, they're called subcritical pieces. When they combine, then we now have critical mass and kaboom. The bottom one, of course, is called Fat Man. And so Fat Man, again, is a very different style. Basically, what we have here is as it explodes, there are going to be kind of like these lenses that force and push onto this little core right here, this plutonium core, that will compress it and then create the shock waves will actually compress the core and cause it to explode. That's Little Boy and Fat Man. And again, they're very different styles of bombs, but they were dropped about 3 days apart in August of 1945, which eventually led the Imperial Japanese army to surrender. Again, here's the actual images of Little Boy and Fat Man, and of course, their devastating power. Again, shot from Enola Gay, which dropped them over Japan. And again, you've seen images of these from Left Behind. Now, like it says here, about an estimated 105,000 people perished in the two bombings, but it's a very difficult number to count because they leveled the cities. And so we just kind of made estimates based on who was not around, but it's not like you could actually count the bodies because they were buried. And this is what Nagasaki looked like afterwards. And this is what Hiroshima looked like afterwards. So like I said, how would you count 105,000 people? I don't even know. So that's, again, a very, very rough estimate. So again, the building, it's called the Dome. It's a very famous picture now. That's what it looked like right after in Hiroshima. And then of course, that building is now still standing. They have not demolished it because they want it to be a remembrance or reminder of the devastating power of nuclear weapons. So that's still there in Hiroshima. You could go visit it again to remind us of what we've done. Now, those are atomic bombs, which again are all fission bombs. So right around the 1950s, we start making a big advancement into fusion bombs. Fusion bombs are called hydrogen bombs. Now, they are a big step up in the devastating power that they have versus the early fission bombs, which ended World War II. These are much, much more devastating. And so basically what they do is they are a two-part bomb. What you have is you have a fission bomb. Notice this looks a lot like Fat Man. So this is a fission bomb, and we would use this fission bomb, which again is equivalent to Fat Man, and then that would be detonated. What it would do is, again, it would create these shock waves, which would then compress this core here, which would then ignite the fusion bomb. So think about this. These are basically bombs that have a atomic bomb equal to what we dropped in 1945 that would then just be the detonator that would then detonate the more powerful fusion bomb. So that, again, is about 1,000 times more powerful than anything we used in wartime. Again, the only two bombs ever dropped in wartime were Little Boy and Fat Man. All of the detonations have been tests. So that's, again, how powerful the new nuclear warheads we have now. So when we talk about the nuclear warheads at the US arsenal or the Russian arsenal or North Korea arsenal, we're talking about these. We're not talking about the atomic bombs up above. Now, here's a little graph to show you basically where the arsenal is, or the quantity. As you can notice, the US and Russia have basically more than every other country in the world combined. Most countries don't even have these, of course, very few do. But the US and Russia have a ridiculous number. And of course, that's all caused by the Cold War. During the Cold War in the 1960s, we were fearful and of each other. So we built a almost stupidly large arsenal, which we are still in the process of weaning down and reducing to get less and less. But like I said, we just have a ridiculous amount. All right, here again is the quantity of nuclear tests by year. So again, this goes all the way back to about the 1940s, right around here. And then you can see the US is blue, the Soviet Union is red, and then everybody else is gray. The number of tests, atmospheric, and then underground down here. So we have had a lot of tests. For example, right here, about 1967, 1968, there was about, I don't know, I'm estimating 85 to 90 tests underground just that year, and the vast majority of them were by us. So pretty crazy. Again, you notice right here in 1962-ish, right about here, it's about what, if I had to estimate, 110, 120 tests, most of them by the Soviet Union and much less by us and nobody else. So that's the number of quantity of nuclear tests of detonations that we've done above ground or below water. The nuclear test locations, again, you guys can see right here. There's the Bikini Atoll I told you guys about previously. 23 tests were there. Again, nobody lives there anymore. We have the Nevada test sites here. The very first Trinity explosion, which was the very first detonation of any nuclear warhead, was right here, right behind my cursor. That's in New Mexico. 928 tests were done out here in Nevada. The very largest bomb, called the Tsar Bomba, was again a 50 megaton. That was done up here in the Ural Mountains, way up here, actually above the Ural Mountains. It's an island. But you guys can see again basically where these are performed. All right, that's it for nuclear weapons. Like I said, this is the bad side of nuclear weapons. But again, the nuclear fuel is the good side and the nuclear power is the good side. And not only that, but nuclear power has trickled down into many things. Proton therapy, if you have cancer, there's many things we do in research that involve nuclear capabilities. So again, it's a double-edged sword, but I'll let you form your own opinion on the cost and benefits.